How many here of you are, I know there's got to be a few of you, are active Redis users? Awesome. How many of you have never heard of Redis before? Awesome. How many of you fall somewhere in between? Great.
All right, so the guy asking you those survey questions has 20+ years of industry experience. He's previously held roles at Netscape. Anyone remember that place? All right. Apple, as well as Apple, Yahoo, Flickr, and GoPro. Please welcome the head of developer advocacy for Redis Labs, Tague Griffith.
Thanks, everyone. Thank you for coming out. I think this is actually my first talk in New York for Redis Labs. So I have a couple scheduled for this week, but y'all are the lucky recipients of my first New York talk.
Welcome!
Thank you. So like many of you who don't use Redis, I'm a little new to the city, but I thought I'd talk to you today about some new features coming out in Redis in both the enterprise product as well as the open source product, and talk to you about how you can use Redis in serving predictive models that you learn out of a machine learning framework. So we're going to start off tonight with a little bit of introductions, and then a bit for those of you who may not be as familiar with machine learning, why we do machine learning, what machine learning is about. I'm going to talk a little bit about Apache Spark, which is a training framework, as well as Redis, and then particularly the Redis-ML module. So introductions. I'll start off with myself really quickly. These days I work as the head of developer advocacy for Redis Labs. So I go around the country and internationally doing things like giving talks about new features in Redis, how to develop using Redis, all sorts of things regarding Redis. My background previously was a systems architect and hands-on developer. I used to do large-scale system development. One of the largest, and kind of the reason I had this job, was I built a system that did about 25 billion transactions a day that used Memcache and Redis. So I've been very hands-on in Redis for many, many years. And when this opportunity came up, I kind of jumped ship from development and embraced the dark side and went over to marketing and started talking to people about Redis. My responsibilities include both my company's product, Enterprise Redis, as well as the open source community. And everything I'm going to talk to you about tonight is applicable to both products. I work for Redis Labs. We are the home of Redis. We support the Redis open source project. For those of you who know Redis and are familiar with Salvatore, Salvatore also works for us and we sponsor his project. We also provide Redis Enterprise, which is an enterprise version of the open source Redis. We've taken open source Redis at the core of our product and built a proprietary layer that handles high availability, scaling, issues that get really you hit when you start building out large scale systems for enterprise and have 24/7 uptime SLAs. We sort of tackle those problems in a way that's a bit more turnkey than what you get with open source. We were founded in 2011. We have a headquarters is actually in Mountain View, California, which is where I'm based out of, and we also have an R&D center in Tel Aviv. When we talk about providing Redis, actually, we provide it in many different ways. We have both cloud offerings and then on-premise offerings. And you can see here kind of a wide variety of the type of offerings we have. And this builds on what you can get with just the open source Redis. Now, for those of you who don't know what Redis is a remote dictionary server. And what I mean by that is it's a server that provides you with several different data types. The way you think of data types coming out of, say, your collections library in whatever programming language you happen to use. You have things like strings, hashes, lists, hyperlog logs, as we mentioned during the trivia part, sets, sorted sets. You can index geospatial data. You can do all of this using APIs that would be very, very familiar to you because they resemble the operations that you can perform in the collections of whatever programming language you use. Is kind of an example here of how you would work with Redis. So Redis is all key value pairs, but instead of the pairs just being buffers or strings, these pairs are those different data types that I mentioned. So you could have a key that maps to a string, or to a hash table, or to a list, a set, sorted set, and on and on and on. It's a very simple programming model. It's very familiar to most people because it really does resemble the primitives that you have in the collections that you see in the first programming languages that you work with. Now, why, for those of you unfamiliar with Redis, might you want to use Redis? One of the big reasons lots of people start with Redis is performance. Redis is an in-memory database, so all data is served out of memory. You can persist to disk, but disk and spinning media is never used for serving the data. So it's very, very, very fast. So one of the things we see is pretty much in any well-running Redis installation, any query you make of the database is going to be served in under a millisecond, which compare that to like a relational store. You're generally not going to find that level of performance. Also, there's this notion of simplicity. Because you're working with things you're already familiar with, there's not learning a new language. There's not learning new constructs. You're really, for the most part, working with constructs you already know. And now the third big reason is extensibility. With the release of Redis 4.0, there's a whole new module system that allows you to extend Redis without having to actually extend the open source software. You can build pluggable, loadable modules like you can in, say, Apache or Nginx to extend the data types, extend the commands, and extend the operations available in Redis. So we'll see later that the module system forms the basis of a lot of what I'm talking about today. But why machine learning? Why do we care? Why did we want to sort of add machine learning features to Redis? Well, what we're doing when we start looking into machine learning is that we're really teaching a computer, by example, to learn an algorithm that's too complex for someone to program. And so when you look at the problems that we sort of start tackling with machine learning, they generally fall into, depending on how you want to divide it, you may one of 3, one of 4 different problems. There's classification problems, which are about picking something out of a set. So you might be familiar with spam detection. Also manufacturing defect analysis or handwriting analysis. Some of the ways we model these in machine learning are models called decision trees, naive Bayes, which many of you are probably familiar with. The next set of problems we look at is called regressions. And this is where we want to score or maybe rank something. So maybe recommendations. How interesting is a blog article to you? What's the likelihood of you purchasing an item? And that's usually represented through a couple of different models, linear regression, logistic regression. Then there's also clustering. Clustering is about finding similar items when you don't really know what those sets of items are. So for instance, I could look at a population of users. Now there's very common things that we tend to delineate people along. You know, ethnicity, age ranges, gender, occupation, income levels. Those we sort of set up a priori in our mind how we want to divide people. Well, you could also use techniques like k-means clustering to find hidden clusters in your data. Basically, what clusters exist, not what clusters you think might exist. And this is used to things for like finding similar items, doing database customer segmentation, or also cohort detection. And a lot of times these are represented by doing a k-means or a hierarchical. Now all of these things are mathematical models. You could train these in any number of systems, and you could serve them up in any number of systems. So if we think about our problem, our training our spam classifier, sort of the general thing we want to do is that we have a bunch of labeled examples. So we know what constitutes spam. We have examples that constitute mail. And we want to run them through some device that will figure out, will learn this algorithm that's too complex for us to program. Now, once we've learned that algorithm, then we want to deploy it. So we've learned this algorithm. Now we have a bunch of examples we don't know. We don't know whether this is spam or whether this is actual mail. And we want to run it through something that will then split up and perform this test and decide for us. Well, it turns out if you look in the market today, and this is in both open source as well as commercial software. This box we understand really, really well. There's lots of different things. Spark, you've got TensorFlow, that people are, actually in this audience, are probably familiar with and have played with. What we're just starting to look at is how do we do this? And how do we do this in a way that we do it out of the box? So how do you do this? It's kind of, we're starting to see some things coming out of TensorFlow. Spark has a little bit. But mostly what happens when people want to build this kind of a system, they build this. This is your typical structure when you're working with Spark. Is you have Spark for your training, so your data, so maybe your spam, your mail, comes into Spark. Spark learns this algorithm for separating the two, and then it stores it to the file system. Then what happens is you end up writing a custom server to be able to use this in production. And so your client apps talk to this custom server that you built. Well, it turns out, and I've done this a few times, building high performance, reliable services are very hard to do. And it would be great if there was something that you could deploy. So faced with this problem, one of our engineers actually used the Redis module system to create a Redis-ML module. And if you look at Redis modules, when you dive into it, essentially now you can use C, C++ to extend Redis. So for those of you who have used Redis before, the gentleman who identified Lua as a scripting language, this provides you with a new non-Lua way of extending Redis. You can, as I said, use it to add new or existing data structures, and you'll see how one of our engineers took advantage of this to build out a whole new way of doing machine learning. And then you enjoy all the features of Redis. So you get all the support for reliability, for managing connections, for scaling, clustering, replication, for failover. And now anyone can do this. You don't have to submit pull requests back to the Redis project to get your code included. If it's something that's really only of interest to you, you can extend Redis yourself and just keep it as a private module. So with that, what one of our engineers, Shai, did was create the Redis-ML module that allows you to serve predictive modules from Redis, predictive models from Redis. So he used the module native API to basically make predictive models, so things like linear regressions, random forests, a native Redis data type. So you have a mathematical model that now if you understand and you've learned it in one system, you can represent it in another system, this system being Redis. Now you can evaluate your models using Redis instead of using your custom server. So you get all the advantages of Redis tuned memory, being able to manage multiple connections as well as failover. You can also store models as hot models. So as they evolve, you flip new models into production. And now, using Redis, you can expand your machine learning pipeline to something like this. You start with your data, you load it into Spark, where Spark does the training. Then the data, once the training parameters are learned, the model is then reconstituted in Redis using Redis-ML, or you can actually do it from any training platform. It doesn't necessarily need to be Spark. And then your client apps talk to Redis using a very familiar interface and a very set of familiar commands. So the Redis module, what kind of things can you represent in terms of machine learning models, predictive models? Well, you can learn, once you learn tree ensembles, you can represent them as Redis data types now, and then you can make predictive inference using tree ensembles. You can use linear and logistic regressions to solve classification problems where the evaluation happens in Redis. You can also perform matrix and vector operations. And as we work more on this module, which happens to be open source, you're also welcome to contribute to it, we'll add more data types and more ways that you can serve your machine learning models out of Redis. So let's dig a little bit into some of these data types, and what do I mean for those of you who may be less familiar with machine learning. Well, one of the models that we represent is the random forest. And what that is a collection of decision trees. And a decision tree is just what you might think. It's a tree representation of a set of rules that decide essentially something by working your way down to a leaf node. And I'll show you an example of this. So in, you can use decision trees and decision forests to support both classification problems and regressions. So you can have your tree end up with either a classification, so one out of a set, or some type of numerical score when you work your way down to the bottom. When you represent your tree, your interior nodes are rules that essentially split your data based on predictive features. So, and I'll show you an example of this. But you know, they could be categorical, so like by day, you split something. It could also be numeric. They could be age, they could be weight, they could be height, things like that. A single decision tree is then basically joined into a forest of multiple decision trees, and you ultimately just take a majority decision over that set of trees. So let's make this a little more solid. So there's a classic problem that you see when you're first learning about machine learning and decision trees, and this is the Titanic survival problem. Would you survive the Titanic based on features about you as a person? So basically, the passenger data gets encoded as feature vectors. And so what do I mean by that? So we break passengers down really into sort of categories that we think might be interesting, that might be predictive of their survival. So their age, their gender, ethnicity, income, state that they were from. Sometimes you could do this manually, or you could use algorithms like ID3 or CART or RPART to do this. And these algorithms exist in many different languages. So there's all sorts of training systems you could use to take this set of data and reduce it into a set of predictive trees. The tree rules that your algorithm or you create are used to infer results. And over here I have an example of a decision tree and how you would use it to predict someone's survival in the Titanic. So it starts off breaking our population into males and females. Well, actually, in this case, it breaks our population into males and anything that's not male, the way the rules work. So if you are male, you move to this side. If you aren't male, then you survived. Then you work down to other properties, and depending on how you are scored at each of these junctions, you may survive or not survive. Now, it turns out one way to improve the predictability of these trees is to combine them into multiple trees or the forest. So in one case, we've learned some rules around gender, age, and SIDPS, which is basically the number of siblings and spouses you have. Country, state, and height, and then some odd things, but this is where machine learning starts finding weird patterns. Things like weight, IQ, and eye color. So how many of you would have thought eye color would be a significant predictor of your ability to survive Titanic? Well, it turns out if you run through certain algorithms, you actually find eye color as a statistically significant predictor of your ability to survive the Titanic. Potentially lots of explanations behind that, but that's what the data is showing us, and that's what the algorithms learn. So let's look at a couple of examples. So we've got, and you know, would these gentlemen survive the Titanic? We have John, who's male and 34. He's married with 2 kids from California. Here's his height and weight, his IQ, and he has blue eyes. And then we have Matthew. He's male, 6. He has 3 sisters. He's from New York. Here's his height and weight, his IQ. And he has brown eyes. Let's use our forest to find out what happens. So here I'm going to switch to a little demo. And hopefully the demo gods will will smile favorably on me. Just a second. Yep, and the demo gods are not smiling favorably against that. I forgot. Build my forest. So you'll see here, the first thing I did was basically create a bunch of decision trees. And you can see kind of the Redis syntax here. It gets very, very difficult. But the trees that I showed you back in this slide, I've actually these are actually learned by an algorithm. I've converted them into a form that Redis can represent, and I've recreated them within Redis. So now, if I want to use Redis to actually predict things, just a second. I can see that using the predictor, neither John nor Matthew survive. I think there's actually might be a bug in this because John should actually survive. But you can see this in Redis, this is how you represent this data. These are the commands that you use Redis. And then this is how you represent John to Redis. And then you run through an evaluation and we look, so tree 1, tree 2, tree 3, that's right. So tree 1 says John survives, but tree 2 and tree 3 say that John doesn't survive. So for the forest, the ultimate decision is John predicts that John would not survive. Now if you look at Matthew, it's pretty much guaranteed he's not going to survive, the poor guy, because all 3 trees say no, and so ultimately the forest says no. Does that make sense? Essentially, it's almost kind of like you're asking individuals to judge whether this person would survive, as horrible of an idea as that sounds. But you're essentially, each of these things predicts individually. And then you use essentially the vote, the majority vote of each of these individual predictions to form one larger prediction. And it's a way of making systems a little more a little more accurate. Oops, sorry. Let me go back to the slideshow. So in Redis, for those of you familiar with Redis syntax, this is how you actually represent the 2 commands used to actually represent this data in Redis. And you can see this is really not designed for people to add these rules. It's really designed for programs and machines to add these rules. And in fact, if you work with Spark, we have an open source module, Spark ML, that lets you take a model, a tree model, encode it in Spark, and then automatically load it in Redis, so you can use Redis as your inference engine. But then if you want to do the classification, the classification is much simpler. You just give it a run command, a forest, and the features. So, okay, this is awesome, you know, Titanic, hey, you know, maybe Leonardo survived, maybe they've been using our models. But how does this, I mean, what does this academic work do for us in the real world? How do we sort of take something that's really kind of a learning example and then apply it to the real world? Well, one of the first challenges that we found was working with ad serving. Of course, it's always ad serving, but the same way you can use these decision trees to decide who might survive or predict who would survive the Titanic, you can actually use them to serve more interesting ads or content to a user. So you could even hand code the rules in terms of what ads you want to serve to a user and code them as a decision tree. Or you can use predictive models to learn what cohorts like certain ads and try to serve out the same ad to people in the same cohort. But so we worked with an ad serving company that needed to serve about 20,000 ads a second. Their data center latency was about 50 milliseconds. The way they structured things, they had about 1,000 different campaigns running, and then they used the forest to evaluate what campaign ultimately got displayed, or campaigns got displayed to the user. Each forest was around 15K trees and about 7 to 8 levels of depth in the tree. Well, by moving from their homegrown solution, where they're using over 1,000 T4-8X large Amazon instances, they were able to reduce it quite a bit and drastically reduce their computing costs. So this is what we're trying to do with the Redis module, is make the serving of these predictive modules, which are getting bigger and bigger and more complex, easier and easier for people to use, because machine learning is changing the world. Whether we like it or not, all of us who are working in technology today in the next 2 to 4 years are going to be involved with some kind of machine learning project, some kind of machine learning feature, some way that machine learning is going to basically work its way into our sort of daily workflows and the features we deliver. So we want to provide a way of doing this that doesn't force you to rewrite the same custom server every time you want to use a new machine learning module. And what we found was actually that we were able to get their serving time down by about, it was 13 times faster to do it in Redis over Spark plus a custom server. Part of that is moving it to memory. Part of it is that we've spent a lot of time tuning and making Redis a very high-performant database. So hopefully this next demo will work, but there's other interesting things you can use for classification for, and I'll show you a way of using these trees to do movie classification. So the pipeline, the tools that we use are basically Python, Spark, Redis-ML, and Docker to sort of containerize the environment. Python is used to basically process data files. How many of you use Python? It's a great language for processing data files. I love it. Spark is used to learn the models. So these are basically the algorithms that are used to discover the forest. We use Redis and our machine learning module. Again, this is all open source, also commercial, to actually serve the results and let you compute things. So the way this demo kind of works and the way the data is structured is we take user features like age, gender, and their ratings against a set of movies, and then generate a predictive forest to see how a user might rate movie 1 through movie n, and in this case we have 10 movies in the demo. So to build something like this, we start with the data. So we took the movie lens data set, used Python to break it down into separate training files. From there, we transformed it, cleaned it up to make it easier to work with. Then we trained it using Spark. So in Spark, we created a random forest classifier. Then we trained it using a fitting, moved it, and then we finally loaded it into Redis. So the final step is to basically execute all your recommendations or all your inference in Redis. And now this is what our training pipeline looks like. We've got the movie lens data transformed into Spark, serving out of Redis. And now clients connect to Redis using their familiar app. Now, let's see if so here, if we look at the code before we run the prediction, we have a user, and we know the user has rated certain movies which are ID'd by number with certain values between 1 and 5. And we're going to use this to predict what they would look at. So using the Spark Learned Machine model serving out of Redis, we can make predictions about how this particular user, based on previously scored movies, would potentially rate other movies. So for movie 4, it was probably their highest. and all of these they probably would not like at all. So you could use this as a basic system for building recommendations and recommending movies. So that, in summary, is Redis-ML. So it's about training with Spark, serving your models out of Redis. And again, I stress, you could do this just as easily with TensorFlow. TensorFlow has now introduced TensorFlow cluster, but that really didn't exist and wasn't available when we started this. You could serve out of Spark with your own custom app, but you're probably better off using a system that's already built to serve large number of connections fast. With one problem we worked with, we were able to get a 97% cost reduction for the resources used for serving the predictive models for an ad company. And honestly, you can really simplify the life cycle. If you go Redis Enterprise, you get all the nice scaling stuff built in. You can also do it pay as you go, so you can optimize your costs, and it's very easy to use. And you actually get a lot of support from us as a company. But again, this is available in both the open source world, it's in our enterprise world, it's available to basically any Redis user out there. All of the models themselves are, modules, and this module in particular, are open source. So you can go to Redis Labs GitHub, you can see the code for this module, you can participate in the development if it's something that's useful, if it's an interesting thing to learn. Please, more power to you. We also maintain a whole registry of modules, most of which are open source, that you can find at redismodules.com. Again, these all require Redis 4.0 or later, which is just coming out. And with that, here are a few places you can find me. I do actually, despite being in marketing, and much to our open source founder's chagrin, I actually do write code. So probably one of the more technical marketing groups in the country. And email and Twitter if you ever want to reach out or if you have questions. With that, I'll turn it over to you. Does anyone have any questions? Yeah, actually, where'd the second microphone go? Back there.
Hi, so my question is that still, I just started about Redis like today, so I'm still a little skeptical about the advantage. So it seems like, if I understand this correctly, that when you have your model trained on another platform, you store it into Redis, which is essentially like a in-memory hash map, essentially. And then accessing the model via that hash map is much faster than not using Redis. Is that you guys are able to improve by that?
Yeah. So the benchmarks we've done, depending on the system, have gone from anywhere from 13, 15 to up to 40%. So when you look at Redis, conceptually it's a hash, it's basically a key map to a data structure. If you look into the underlying internals though, nothing is really represented that way. A lot of work goes into both tuning the connection side of things, the memory management, and essentially the response time. So essentially you're basically piggybacking on all the work that's gone into building the database to essentially get to improve the performance of your serving layer.
Who are the major customers for these databases?
Sure. So we have a lot of customers who use the enterprise version in finance, people like Starbucks, Visa, Kohl's, Docker. It all depends on the use case. So if you look at open source, Redis is actually voted the #1 beloved database of developers by Stack Overflow. So we have a lot of Redis in production in both the open source and the enterprise.
Seeing this system, it opens a question for me, which is, it's very good to have these predictions, but how do you validate that your models are correct so that when you're getting a prediction, it's not just something that it has no basis in fact?
So that is actually a problem for the training system. So on the Redis side, it simply serves up the parameterized model. So let's say, for instance, we're talking about a linear regression. Something learns the parameters of that line, and then Redis just evaluates those. On the learning side, it's actually very important what technique you use, what algorithms you use. Not all machine learning models can represent all data sets accurately. For instance, there's a concept called linearly separable, mouthful, but essentially certain classifiers can only represent a line or a plane if you look at it as a multidimensional mathematical construct. So if your data can't be accurately represented with basically split with a single plane, that's not a good classifier for you to use. So there's other things that various, so for instance, if you look at like softmax is another algorithm. Softmax will get you about 92 to 94% accuracy on analyzing handwritten data sets from the classic, the traditional handwritten data set for machine learning. There are other techniques that actually are much more accurate. So normally when you do this, you do a train and then you do evaluation. And a lot of times you'll iterate on that. So you have a set of labeled things, another set of labeled things. So you have your training set, you run that through the algorithm. You then run your validation set through your predicted model to see how well it ended up, and use certain mathematical functions to then start tweaking those constants. And then you iterate on that until you get as close as you can to your validation set. Now that said, there's all sorts of techniques that you then have to deploy to keep that those models fresh and up to date and still accurate on your current set of data versus what you trained on.
Okay. So actually, it's a two-part question. So is it that currently you can only deploy the model developed with Spark ML, or any other, let's say, if I tell same regression model, if I develop in R, can be deployed to Redis? Is there a common serialized format of the models that are generated by these two training systems?
So I'll handle part one first. So you can use any training system and any evaluation system as long as it's one of the model types that we support. Because when you look at the models, they're actual mathematical definitions. So for instance, I always go back to like linear regression. Linear regression, you're defining mathematically a line. So there's 3 or 4 constants you need to essentially learn, and that defines your model. And when you load that into Redis, that's what you're loading. You're telling Redis, these are my 4 parameters for a line. Hey, we're golden. Now predict using that particular line. So as long as you can create those constants, you're good. In the case of Spark, we've actually built a module to do it automatically. It's written in Scala. You load it into your Spark environment. It automatically takes the constants out of a Spark model and loads them into Redis for you. You could do the same thing with R or TensorFlow, provided you wrote that code. That code just doesn't exist today. Does that answer your question?
So you mean to say like you have to extract the functions out of the model and then feed into that?
Yeah, so for instance, I know you mentioned Spark. For instance, if I took Spark, I could use the Spark, R. I could use the Spark rpart function to basically learn a set of trees. But I would have to manually take those trees and decompose them into the rule format that Redis uses right now, because there's no R module that does it automatically. The microphone's going around that way, so.
I have a couple questions. One, can we find this presentation online for later reference?
We'll post the video on that.
Yeah.
It takes about a week to get up, but yeah, we'll post that on the meetup available.
There'll be a link on the meetup. Okay, perfect. Second, since this is Redis and there's a ton of Redis clients out there for all different languages and frameworks, does that mean that all those different languages and frameworks can access the results and use Redis-ML?
Yes. So you can use it with any Redis client you're using currently, because pretty much all Redis clients have an execute command escape. And that's one of the things with not modules, not just the machine learning module, but all modules, is that you either need to extend the clients, or as a developer, you have to use the escape. So in the case of the modules that we Redis Labs have done in open source, all of those we've extended. In case of Python, we've extended the Python client to have actual API calls, so you don't have to use the escapes. And then also for Redis, we've done some extension to Redis so that you can use the modules the same way you would use any other Redis API.
Cool. Okay. So if you had like a React app or something, you could like query directly or something.
Yeah.
And then one last question. So in terms of the models that are supported right now, would you say it's like most of the common models that out there are supported at this point?
Yeah, it's generally the common basic models that people use more in sort of real-time systems. The one thing that Redis-ML doesn't support that's starting to grow and is common now is neural nets. There's actually a Redis neural net module that Salvatore wrote, but it's separate from the Redis-ML module. So if you learn your nice neural nets in TensorFlow, there's not a good way to bring them over to Redis yet.
Hi there. I have a question that's a little more managerial.
Uh-huh.
We've covered a lot of topics that kind of cross some concerns here, and I think the audience is like filled with DBAs and engineers and data scientists. But what we cover here kind of crosses all that. I'd like to hear your opinion on the future of this. I think a lot of companies are trying to hire folks that can answer these questions, but the skill set crosses like 3 different jobs. Mm-hmm. Are we supposed to just all learn all of this, or I'd like to hear your thoughts.
Yeah, I actually think more and more of us will be doing this as part of our job, even though we're not necessarily, say, a data scientist. I think, you know, when I started, I worked, or when I sort of first started seeing machine learning was back in the late 90s with a company that did sales software. So we use various machine learning techniques to find either clusters of things to represent, to upsell people and things like that. Back then, basically, we had 5 or 6 PhDs who none of the engineers liked, who were all shoved off in a corner. We didn't like them writing production code because they wrote horrible production code. And my apologies to anyone here who's a PhD. But there is this big sort of dichotomy between, you know, the people doing machine learning who literally were like reading papers every week and it was very academic, and then the engineers who are building a production-ready product. I think the reality is that kind of model at a managerial level is absolutely changing. Because when you look at things like TensorFlow, you look at Spark, you have all these modules or libraries that have maybe not completely commoditized machine learning, but for some very basic applications, you no longer need this fleet of annoying PhDs off in the corner breaking production. You can just assign this as part of your mainline feature development. So I think more and more of us will be the same way, say we learn a React or we learn how to write MapReduce jobs in Hadoop. We'll be either doing this or sort of partially specializing in the machine learning. Now that said, I think we'll still have data scientists because everything I've shown here, these are techniques from like the 90s. You know, none of this is cutting edge. None of this is, you know, super amazing cutting edge technology. I think you'll still see specialists in this doing the data analysis, generating predictive models. But I think what will happen long term is it'll become the learning systems will become commoditized as well as the serving systems. We're already seeing that with the learning systems, and we're just starting to see that on the serving side of things. Yay! I guess you agree.
Yeah, that's what we're seeing, but it's weird. It's changing like faster than we can accept it.
Well, I mean, I've been around for about 20 years. When I first started developing, there was no such thing as a collection library. Like, we literally wrote our own collections every time we worked on a new system. And you know, now it's basically, you would never even adopt a programming language that didn't have a standard set of collections. In fact, one of my second jobs out of college, I basically built kind of a collections library and worked on a collections library for the company because we thought, hey, we should probably centralize this and have everyone use the same thing. And I mean, it's just, the reality is right now technology is still changing at a very, very rapid rate. I think the reality is our jobs evolve, are probably very different in 5 to 10 years again. Every 5 to 10 years, they seem to change pretty dramatically. I know there's lots of questions. I'm not sure where the microphone
I got one. So if memory serves, I don't know about version 4.0, but Redis is single thread.
Yes.
Right? Yeah. So if you're running these models on that thread, I guess I'm curious if you can speak to what kind of throughput penalty or cost you might pay just in the Redis server itself when you do this.
Sure. So I would not run this alongside my, say real-time, hash. So I would run this as a separate Redis so you could control the latency for that instance. It's still new code, so it's not necessarily as performant, but it's quite fast. You're generally talking in the 1 to 2 millisecond range for any operation. Everything, if you look at the matrix operations, are optimized matrix operations. They aren't, they aren't naive algorithms and we actually use matrix, open source matrix libraries to handle the matrix operations. So it's still really fast, but like I said, I also come from, like a production environment, 24/7. The system doesn't go down. So for me, this is still new enough that I would put it in its own environment to serve out the recommendations as a separate request. I wouldn't try to mix my other Redis traffic with it yet. I think you'll still find it's fast, but some of the models are a little slower to evaluate than just a hash key lookup type of thing. Sure.
So my question might in some way reflect my own naivety with Redis, but I'm struggling to understand, maybe like some other people who spoke before, like where does this fit in the workflow or in the pipeline, and like what has to come together for this to be faster than Spark, whatever that means. Like, so I'm gonna have to load stuff into Redis anyway in order to have it there to be able to run the predictions. Actually running the predictions is usually very cheap anyway, so what do my usage patterns have to be for this to be sort of quite faster than just running prediction as I put it in? Is it when I want to run predictions repeatedly on data that's generally static, or what does that look like?
Sure. So I think where you get the performance gains in a Redis-based predictive engine is simply from a couple of things. So everything in Redis is in memory, so you're never hitting disk, which may or may not be the case if you're using Spark in a custom app. If you deploy a Spark app, you may actually have your models files stored on disk, so you have essentially your disk transfer time. Generally, with any predictive system, it's going to be sort of train once, predict thousands of times for it to be valid. Essentially,
Would you say thousands of times on a given piece of data, though?
Not necessarily on a given piece of data, but you're going to use the same model over and over and over and over. Yeah. So, for instance, going back to say like the serving company example. So you take Spark, you learn a set of rules to determine what's the optimal or close to optimal ad presentation for a user based on whatever features, maybe their demographics, prior purchase history, etc. So that's represented now as a mathematical model. That can be loaded into Redis. Now, every time you want to actually evaluate a decision as to which ad to serve to that user, you take the current user's features, run them through that trained model, and that's where you get the performance enhancement, because you're not having to build a custom application to do that. You're using an off-the-shelf database and component technology to basically build that inference system. So in the past, you would have to build the inference system yourself, which included handling inbound connections, buffering, returning data. Now, you essentially just load it into a pre-existing system. Does that kind of answer your question?
Yeah, I think so.
Okay, if not, find me afterwards and I can talk you through it in more detail.
Do your PhDs and faculty and scholars of your office, do they still write articles about decision trees, or they venture already into neural net models or something?
Yeah, so if you look at what people are doing really on the cutting edge today, it's the big one is deep learning. So deep learning networks can take days to train on large clusters of machines. All of this is, I mean, all of this stuff is really stuff you can pull out of online tutorials, you know, undergraduate, graduate texts in machine learning, Coursera, you know, Andy Ng's course. None of this is state of the art, but these are the things that people are using to get into machine learning and apply intelligence to the features that they're developing. It turns out a lot of times you don't, for a lot of applications, you may get enough statistical benefit from simplistic methods. You don't need, you don't really need the most advanced methods. But when you start looking at what sort of cutting edge or really cutting edge, not bleeding edges, now the deep learning, multiple layer neural networks, and those can take days and days to train. If you look at what they're doing with TensorFlow, a lot of times they're giving out pre-trained models that then you strip out essentially the top layer and you retrain, because it takes so long to train them that they're not yet, basically those models aren't really trainable on, say, like an Android device. So if you wanted to use it on Android, you sort of take a pre-trained model, retrain it for a little bit, and then deploy to an Android device. So there's a lot of things going on sort of in the whole space of machine learning as it basically goes everywhere.
All right, Tague will be here for one-on-one questions because there was a few hands who didn't get a chance to talk. So please come up right now and talk to Tague. Thank you very much, Tague. Griffith, thank you all for coming.
Thanks, everyone.